let's take a look at a few more examples, beginning again with the logical not operator. So let's skip the value here. So all we need to know is that is hungry is a Boolean. Let's skip straight to the if condition here. So if not is hungry. So the way I would read that in my head, if they're not hungry, then they're going to print out the message, no need to eat now. That makes perfect sense, right? If they are hungry, it'd be a different message, right? But if they're not hungry, because the not operator here, then we don't need to eat because we're not hungry. So what is actually happening code-wise, right? Logical operator-wise. Well, the not is going to take whatever the value of is hungry is and reverse it. Because we named our variable is hungry, it does make sense when we read it out loud as well. But let's look at the actual value of is hungry. So in this case, is hungry is false. So currently they're not hungry. So rather than creating a new variable, right, we're just going to use the not operator to describe the not hungry state. So not is hungry. So let's see what happens if we throw a false in here. So if not false, so opposite of false. Opposite of false is true. So if true, so this would indeed evaluate to true. So this would execute, and then we'd have the no need to eat now message printed out because it reversed the value of is hungry. That's the not operator. Pretty simple. Let's look at the and operator. So this is now chaining two things together, right? Remember with and or, we have a left side and a right side. All right, so now again, we're going to skip the actual values. We're just going to see username correct and password correct. So in our and expression here, in our and um, logical operator, we have username correct on the left and password correct on the right. So with the and operator, both need to be true. And it's always going to check both, right? Because even if one of them is true, we always have to make sure that the other one is also true. So with and expressions, there's going to always be two checks. Once we get to or, you'll notice that it's not always two checks. Sometimes it's just one. All right, so username correct and password correct. That makes sense. If both are correct, both are true, then we're going to say they successfully logged in, right? This is what it might look like, right? A simplified version, right, of a real system. All right, so this expression, this login successful, is only going to evaluate to true. This is only going to execute if both of these variables are true. Let's check. Well, we have a true for username correct and a true for password correct. So both are true, so then this will successfully execute. This indeed does work out. So this code will run. All right, let's look at the or operator. So I said with the and, both have to be true. With the or operator, only one of them has to be true. So that means we really only check from left to right. And as soon as if the first one checks out, then we're done because we only need one of them to be true. Now, if the first one turns out to be false, right, then we have to go and check, our second case and hope, cross our fingers, hey, is this going to be true? Now, obviously, right, when I say cross our fingers, you don't always want the expression to be true, right? Sometimes you want it to be false. But I'm just saying, right, in terms of evaluating these expressions, I always like to think positive. All right, so let's see. Is raining or is cold? So if it's raining or it's cold, we're going to take a jacket. That's what this message is saying. So now we're actually going to plug in the variables. So how would this work out? So we're going to check first is raining because with the or operator, we only really care about one of them being true. So is raining is true. Oh, there, that's it. I don't even have to check is cold. I'm done. Um, this is going to bring us to short circuiting, a concept that's important with logical and Boolean expressions. The order does matter, as it turns out. But yeah, because is raining is true, we no longer need to check is cold. We only need one of them to be true, so we're done. This does indeed execute. Because it's raining, we're going to take a jacket. We don't care if it's cold. It's already raining. So yeah, first checks is raining to see if it's true. If it isn't, then we would check is cold. But because is raining is true, and for or, only one side needs to be true, the whole thing is true.